All right, hi everyone. How's everyone doing? Thanks for coming to a little bit later presentation here. I appreciate that. So I'm Jeff Dickey. I work for NetApp. I have this awesome job where I get to travel around and tell companies about the awesome cloud products that NetApp has. And I'm excited today because we have a customer here, and we're going to tell you a story. It's going to be a journey of what our customer GMI went through, kind of in their cloud story and specifically towards storage. So I want to introduce Jason, or let Jason introduce himself.
Sorry, I'm Jason Mulready. I'm from Genomics Medicine Ireland, and we're a genomic sequencing and a research company.
Awesome. So a little bit about GMI. We're going to show this video. It's a great video that kind of gives an overview of GMI.
Imagine a future where complex diseases and conditions can be identified from birth, allowing them to be successfully treated before they become chronic. Imagine that a blueprint of your unique makeup can be used throughout your life to tailor new treatments and medication for you as soon as they're developed. And imagine that the participation of 1 in 10 people in Ireland can benefit those living on our island and also the 80 million people worldwide who call Ireland home. All this is already becoming a reality thanks to genomics, the most significant development in medicine and life science in generations. Now imagine that Ireland can become the global leader in advanced life sciences, because studying our genes today can lead to amazing discoveries tomorrow. Sizable new investment will create up to 600 jobs and will be the foundation for one of the world's largest whole genome sequencing programs, targeting 400,000 participants with potential to establish Ireland as a centre of excellence in advanced life sciences. So imagine that Ireland can become the envy of the global life sciences community and at the forefront of one of the most groundbreaking developments for humankind in decades. Imagine no more.
So no big deal, right? That's not a huge, amazing feat that you guys are working through. Can you give us a kind of a step back and tell us about GMI?
Right. Well, GMI is about 4 years old at this stage, and I joined it. It's fairly early days. I was about a year and a half, or when I joined, and we were very much. We were starting this from scratch. There's nothing like this before out there. And we decided as a company that we were going to be just cloud-centric. We weren't going to do any on-prem infrastructure or hardware. And when you get to a situation where you're generating a lot of data, that can be a real challenge to be a cloud company, but creating tons of data in the actual real world.
So you guys create, I mean, it's almost like tangible data, right? You're taking the physical and creating data?
That's right. Like these sequences that are coming off these sequences, like an individual sequence could be 200-300 gig a run, and then if we're running those multiple sequences off these things being captured on just even one sequencer alone, you could have like nearly 100 sequences on that one sequencer. And like I said, we've 6 of them now at this stage, so that's a lot of data to be pulling off the physical devices and pushing into cloud.
Yeah, that's awesome, and such a great use case. I think folks here have either have gone through projects where you've got massive amounts of data to get to the cloud, or at your next gig you will have that problem. But let's talk about what were you trying to do? Like, what are you trying to accomplish with your cloud build?
Okay, well, anybody who's tried to do file storage in the cloud will know it's difficult. And then trying to do high performance file storage in the cloud is almost impossible. We evaluate a lot of different tools out there, a lot of open source tools, Ceph, Gluster. We've even gone down the route of actually working with AWS and replication on Windows. And that was looking like the front runner for a long time. They're using replicated services across environment-based instances.
Okay. How was that?
It's good when you get it running, but there's a lot of work, a lot of heavy lifting to be done to get the kind of performance you want and get your own sort of comfort levels that you're not going to lose data.
Yeah, That's probably important in what you guys are doing. So what were some of the requirements that you were looking for early on? Like what you had looked at Ceph, you looked at Gluster, you were about to look at another one. What kind of led you into the kind of DFS thing?
Well, it was kind of interesting. We were playing around with DFS and we're very close to putting that into production. We had it running with 1 or 2 sequencers there. And we had a meeting with our colleagues in Iceland. We have a team over there. And they were advocates of your product there. And we looked at the product initially, and it was a good product, but it only would work inside Amazon. And that was the main pain point for ourselves. That great product, but not really going to work for our use case.
Yeah. Which kind of gets us to the the before using NetApp, right? What can you kind of talk to us about scale and what it looks like with the data? What were you trying to do? What were some of the gaps that you were encountering with using these different storage software?
They're all good solutions in their own right at a very specific use case. But when you're in a situation where you've got a lot of data, you're generating large volumes at a long time, you have to figure out how can you get this data into the cloud without losing it, and how can you do it at scale. If you've got a sequencer that drops data, that's quite a serious event for us.
Yeah.
There's a lot of work, and even physically running one of those sequencers, you got a lot of lab tech work. You've got a lot of costly consumables to run those things. So we've got to be sure when we write that data somewhere, it is where we expect it to be. And then we've also got to run some sort of process and analysis on the data and conversions on that data on different pipelines.
What happens if there's if any data gets dropped or you lose a small amount?
We're talking about a significant cost to the company and actual also time to get that data into the cloud. So each of these sequencing runs will take 15, 20 hours. And we've got teams waiting on this data to do analysis and research. So you're talking about the whole cost of actually preparing new blood samples again. So you got lab tech costs, you've got consumable costs on these machines, and you got the physical time to run that sequence again to get it back into the cloud.
Yeah. So huge data set. You rolled it yourself.
Yes.
You've got a small team. What were those challenges?
Well, very early on, when we started looking at the likes of Ceph and the different solutions and DFS on Microsoft, we realized we didn't really want to become storage administrators. Because you're not just rolling in one server every time you spin up a new one of these storage nodes. If you're using something like the DFS cluster we were talking about, you're talking a pair of large ephemeral servers, lots of disks in them, lots of potential for failure there. Yeah. So every time you're scaling up times N2, like everything. So if you're going to put one of those for every sequencer or for every piece of lab equipment, before you know it, my DevOps team are going to be in a sort of storage administration kind of mode.
And a lot of that's maybe hard to automate, especially on the physical side too.
Well,
AWS?
You can do an offload with Amazon with their automation tools, but at the end of the day, when you're dealing with a lot of sort of potential information, a lot of critical information, you do want to have a human eye on it and check that what you've saved is what you've actually expected to get there. There's nobody's going to thank you for saving an awful lot of junk data into Amazon or into S3 if it's not actually what it's supposed to be.
Would you have to resubmit a job from on-prem?
It has happened from time to time when our own solutions where say something would crash out or whatever, and the drive didn't get there. You got to go through sort of recovery mode in the sequencer, see if you can recover the data from the sequencer, push it back to your storage solution. Then you're going to have your old pipelines, or you're going to have hundreds of instances working on that drive, converting that data into something usable. Then we're going to commit to S3 where it's going to be its final resting place.
And that would be cost prohibitive if you have to redo it a few times.
It's not something you want to be doing every day of the week, right? Yeah.
Okay, so you found out about NetApp Cloud Volumes, right?
Yeah.
And what was that like? How did you hear about the product? What were you looking for?
We were over to sort of fact-finding mission with one of our sister companies, and we were looking at their products and what they're doing, and they were doing large-scale analysis in the cloud, and they demonstrated the cloud volume and how quick and how easy it was to get up and get going. And I really liked the product, and I was becoming an advocate, even though it wasn't really for our use case. The Achilles heel was, if you had an Amazon machine, you could access NetApp. but not the actual on-prem thing. So that was the kicker for me, because I liked the product, but I just couldn't see how it worked for our case, where we're in the real world and we're not 100%. Everything doesn't happen in the cloud. We kick the real sort of work off in a lab, in a laboratory, on a sequencer, and generate lots of data.
And how long did you test that?
We played around with it for a while, and I'm saying we had a lot of help from your team there on the testing and making it available. All right.
Yeah, well, that's awesome. So this kind of changed the way you guys were basically getting this on-prem data to AWS. Kind of did you have to retool anything? What did that look like after?
Yeah, well, even taking a step back, engaging with NetApp guys, your support team, your engineering team. Typically, like I said, all the cloud volumes are only available in the cloud. So we did a bit of funky networking with Amazon, Direct Connect and that kind of thing, and we changed how you present your NetApp product. So it wasn't the standard customer placement stuff. We had to have the engineering team where we're placing Direct Connect straight onto the VGW of an Amazon VPC, and then doing some routing on our own side and in the Palo Alto world on our firewalls. We're able to make those drives accessible inside our environment. So we had the situation where we could provision a NetApp drive, have the sequencer think that it's actually talking to a Windows file share, and as far as it was concerned, it was happy they're writing onto a Windows server.
That's pretty cool. So I want to just dive into that just a little bit. So
yeah, sure.
Talk about the sequencer. What is this? What is this thing?
Okay, well,
we're talking about
these sequencers, they're a very expensive piece of equipment, and they're very sort of strict about the software stack on those machines. Installing something like an antivirus product, that could even invalidate your warranty with the vendor. When you're spending like £1 million on a sequencer, you don't want to have a situation where the vendor is going to turn and tell you, we don't support it because you got a strange config or something we're not happy with. So when we looked at all these other open source solutions like SIF or any of these things, they always required an agent or a piece of software to be installed to make them work.
Because these are in an office.
Yeah, they're actually in a laboratory.
They're in a lab, right? These are crazy expensive machines. Yeah. And they're basically just they're almost like data generating machines,
right?
Oh
yeah, these things will fill your drives pretty fast.
They want to put the data to a local drive in your office, right? That's what they want to do.
Absolutely. Yeah. These people that build these machines, they're scientists. They're at the top of their game from all the medical sciences and the sequencing and the imaging. They're not thinking about sort of cloud. They're not necessarily focused on cloud. They're used to working in traditional environments where you're writing to Windows file servers, and that's what they know and that's what they do best. So trying to bend that product to work cloud it was a real challenge.
Yeah, yeah. And is everyone familiar with Direct Connects? And is that kind of a foreign thing? Do you want to describe that?
Yeah, so Direct Connect is effectively a lease line into the Amazon infrastructure. And in our configuration, we have a 10 gig Direct Connect Amazon pipe, and you can actually access the Amazon services, API services, S3 and DynamoDB, those kind of things, at 10 gig speed from your on-prem. So that's a big game changer when you got a pipe like that directly into the core of Amazon.
And what I love about what you guys are doing, I mean, when I was introduced, it was like, oh, hey, this company has a really unique use case for doing this. And then when I got to talk with you, it was like, well, no, this may sound unique, but I think in the future we're going to have so much more of this, right? I mean, you still have a lot of data creating entities, oil rigs, where there's so many things that are generating this, and how do you get it to, you still need massive processing against that. Sure. You're not moving servers out to your data, right?
No. And even looking at something like the Amazon Snowball product or something like that, they wouldn't work from a point of view. You're talking about you bring an Amazon device to your premises, you load the data up, you ship it off, they ingest it. There's just too much of a delay in that situation because our stuff is very real time.
Yeah. Because it's an awesome product for that.
Yeah, for that specific use case.
But if you need that, if you want real time, getting your data in, and then talk to you a little bit about this. You were saying that kind of freed up your time to focus on more.
Yeah, like I said to you, we've a relatively small DevOps team. It's 3 and 4 sometimes when I roll up my sleeves. And looking at the sort of the trajectory we're on with the DFS solution, we're going to have a situation where, Monday morning, who's going to have the bucket and mop and go and check what's going on with these instances. When you're running something like that D2 8X large instance, which has 24 2 terabyte mechanical drives, if you run enough of them, you're going to have drive failures. And Amazon has drive failures all the time, but they build redundancy into their products. But when you're using the ephemeral-based instances, you've got to build that redundancy yourself.
Yeah. Well, I remember when we first talked, it hit me because the head of our cloud unit is always saying, innovate, don't administrate.
Yeah,
and
yeah.
I remember when we're talking with you, and you're just like this freed you up, right? You're
Yeah,
not having to think.
absolutely, yeah.
You're getting all the benefits of AWS, but you're not having to roll your own, network storage.
Yeah,
on
like
top of that, right?
we didn't want to become storage administrators again. I've done that before in past lives.
Okay, so there were three big things that were, let's say, obstacles or hurdles, right? That you need to do. Can you talk about each one? I know scale. I mean, and both on-prem scaling and both scaling in AWS.
Yeah, well, like we said, we never we started out as a company that we're cloud centric, and we didn't go that route. When we did agonize, do we put a physical storage device on the premises? Then if you can have one, you have to have two because you got to have redundancy, and also you're going to be limited by your capacity or whatever you can put on prem. Even the biggest systems, with the kind of data sets we have, like there's other, say, research or other sequencing companies in, say, the UK where I think they've got about a 2-week retention on their data because they've obviously got a limited hard cap on what they can hold. Yeah. Where with cloud, you can just scale infinitely. Even going back to like what I was saying to you about the sort of the pipelines that we have analyzing this data. Once we get it from the sequencers into NetApp, we can have 400 plus instances chewing away on a NetApp volume, consuming that data and making it something usable in S3.
And are you able to say, like in the last few weeks, like how much data have you moved or?
Well, I think last month there, we could be talking nearly close to half a petabyte of data just being moved from the sequencer. Now, obviously, there's a lot of junk data. Once we've processed it and turned it into something usable, you're going to throw a lot of data away. But that's the kind of volumes of data that we're pulling straight into NetApp, and then we're basically processing that and then turning it into a sequence on S3.
But you have to process the garbage out.
Oh, absolutely, right? Absolutely,
yeah.
And that's part of our workflow, yeah.
Yeah, and that takes time. So cost, that was something you were looking at, or?
Yeah, well, like I said to you, when we looked at the ephemeral-based instance solution, it was much more expensive than NetApp, and you weren't getting anywhere like the storage you needed. And we're looking at a hard cap of 44 terabytes available on those D2 clusters. So you're paying for 80 terabytes, but you're only getting 44 terabytes usable in that mirror configuration.
Yeah. And what are you doing anything with the cost savings, or do you just reap the cost savings, or do you reinvest that?
Well, that's something else, we can spend in the organization, be it on research or be it on other things. So it's good, taking that storage stuff away. It also, there's a human capital aspect to this as well. If you don't have people managing your storage, they can be busy doing something else. They can actually, add more value in the company. Yeah. So it's not just a dollar figure.
Or it gives you more spot instances.
Absolutely, yeah.
Yeah, and then talk a little bit about the network traffic, because that's I think anyone that's here at this conference understands like that much data and what that looks like and why that's a challenge.
Yeah, like these sequencers when they're running, like they can take 15, 20 hours to basically get their output out and onto a NetApp drive, and then we'll kick off some workflow there where we'll actually have our pipelines come along, do processing, do PCL FASTQ conversion. Then we've got to do quality control on those samples. Once we're happy with them, then we're going to commit those to S3.
Okay, nice. When you first started this process,
sure.
What did this look like? Kind of walk us through setting up the trial.
Okay, so when we're setting up those D2 instances, you'd spin them up, and you're probably talking about, from a situation from launch to configuration ready to go, you're talking an hour to actually go, because you're also going to do replication tests, make sure that you can recover there, your data is moving across. And what we found as a challenge with the Microsoft DFS service, it really struggles when you're sort of trying to replicate large files. if you've got your standard file and print that you have in your Office or Word documents, DFS is a beautiful product. You just turn it on and it just works. But when you have a situation where you've got, large data sets coming from multiple sources, like multiple sequencers, that can be challenging. You start getting replication lag.
Yeah.
And also you're losing a lot of that bandwidth you're going to have in those instances just in pure replication traffic as well. So you might have a 10 gig Amazon instance, but realistically, you're probably losing half of that bandwidth just replication to keep those two instances in sync.
Yeah. That's kind of a good point because it's a good product, right? It's like right product, wrong use case.
Absolutely,
for that,
absolutely,
which
yeah.
is, I think today we're bombarded by different products to.
We can have too much
look at,
choice,
right?
and
Yeah. And then so connecting, you'd spin up, you connect the sequencers directly in, right?
Yep.
And then you're doing the sequencing on that.
Yep.
And then. What was sorry, I had to read that. Then you're analyzing the data, right?
That's correct, yeah.
And just right then, you started. There was
Yeah.
no delay. Okay, that's great. So the other thing I kind of want to touch on too, because it's just these machines are so fascinating. It's not like you're not done with data, right? You're not done with your data set. You're not done moving data. This isn't something that you're just going to work with, right?
We're continuously going out there and collecting more samples and processing more samples, so that we're generating more and more data all the time.
What percentage do you think you're at right now of the goal for 10% of Ireland? Right?
Maybe 10% there. Yeah, we've only collected a small subset. Like we're only starting this. This is a long-term plan. This is going to take years to actually finish. So, yeah, we've still got a long way to go. I don't actually have the actual right number on the samples there.
Yeah, that's going to be a long journey, and I think time will tell, right?
Yes, it's going to be a long story.
What will work, and with different things that change. Were there lessons learned from moving kind of again large data sets to the cloud? Were there things you would have done different, or were there things that you do like the way that it's working now?
Well, like I said to you, when we're rolling our own storage solutions, it's very hard to do capacity planning and that kind of thing. And you spend a lot of time agonizing over, am I making the right choices here with instance types and that kind of thing, building your replication suite and that kind of thing. So moving to NetApp, we've kind of offloaded a lot of that sort of mental headache there. We're no longer sort of worrying about storage and optimization of those servers.
And you guys had a requirement too for a dual protocol, and I always laugh because it's like if you're not a storage person, like when someone says dual protocol or storage, or if they say NFS, all the different things, or people are like in the cloud, like what? That's not a thing. I think even NFS storage has kind of gone away. Just even thinking about it, because we're so used to saying like how are we going to build this, right? It's block, it's object. Like we have to re-architect. So it's kind of it's almost like a resurgence of file again. So do you explain dual protocol? Because I cloud folks. It's just not a term they.
Well, I think everybody knows NFS is the old tried and tested Unix file transfer protocol. CIF or Samba, depending who you're talking to, is the sort of Windows emulation of the Windows file sharing protocol. And like we said earlier on, these sequencers are all running Windows embedded operating systems or long life systems on them. So they want to live in a Windows environment. They're not going to talk NFS. So like I said, these machines are heavily under sort of regulated software controls, what you can and can't install. So even if you could go and buy a commercial NFS agent to install on these things, you're going to have to work with the vendor, get a sort of validation of that, and it's just such a headache. So having a sort of dual protocol where you can write Windows file protocols to the NetApp volumes, from my perspective, was a game changer, because we did look at it, even stuff like the Amazon EFS product, but that only comes in Unix flavor NFS. So, great product, but just again, not the right product for this use case.
Yep. Well, and so the sequencers want a Windows file share.
Yeah.
Right.
Yeah. Basically.
And so you need that same share, but you're processing. You're doing the analytics on Linux machines, and they both need to see that. So it's I think for folks to understand, it's like if you need Windows and Linux machines all accessing the same
data,
file store of that. So it's kind of a unique thing, but it's definitely needed. What's your current on-prem storage footprint look like?
You can see it there. No, we have absolutely no servers on-prem at all. Everything is run on the cloud. Even our office environment or AD, the whole lot, it's all Amazon based. And that was the real sort of agonizing thing when we were struggling with this problem. We were trying all these different open source solutions, and it was a close call. Do we look at a real physical storage solution? Where are we going to host that? Are we going to put it in our own data center, or where? And like I said to you, do we need to buy two of them? Where are we going to put them in different locations? And all of a sudden, that gets very costly, because if you're going to start hosting your own storage solutions in different DCs, you're going to be paying for connectivity, the whole lot. And again, you're going to need people to manage that, and that would put a lot of pressure on my own team. And we did a sort of back of the napkin calculation if we turned into, storage admins and started running physical infrastructure on things. And if we started running servers and started running storage, our team of say 4 DevOps people, you're talking 10, 15 people just to keep an eye on that thing and keep it running and be there 24/7 and make sure things just stay running. So we did not want that sort of burden of managing all that resources. So persevering on the cloud and finding new guys and working with your team around the whole bending the product to work on-prem was a real serious game changer.
That's another thing that really excited about me with working with you guys is this is not a normal scenario for anyone doing kind of the type of work from taking a blood draw.
Yeah.
Sequencing, because I in my past I have built sequencing farms, and it's very rare to see that, and that's why I like it, because this is going to be a future use case. I think more, you're paving the way for more companies that do generate a lot of data.
In the real world,
that can now they can actually process it in crazy speed on AWS. So that's awesome. So can you talk a little bit about, you have massive data sets and the sequencing. We've talked about all the what you're doing, but what's important to you? It's not necessarily as a DevOps person.
Yeah.
What are you concerned with? Like, do you care about recoverability or data integrity and what do you do about that?
Yeah, so like I'm saying, we're at every sort of touch point of our data, we're doing sort of analysis and checking things and check the state of data, the integrity of data. That's like one of the main reasons why we use Amazon, because they have a lot of built into their products like S3. So once you get your data, through the hurdles have been processed and out, you can be fairly confident it's good. But it's a challenge, and it's a long journey to get from the real world to get there. So having a sort of durable, reliable storage like a NetApp platform really, really appeals to us. It makes our life so much easier. Yeah. Provisioning the whole management side of things. We're not thinking about servers or placements, what AZs we're going to place them in, how we're going to space them out. That's effectively your guys' problem.
Yeah. Well, I mean that's cloud, right?
Yeah.
That's the promise of cloud. What do you guys do? What do you do as far as recoverability? Like, how do you sleep at night?
Well, in the scenario we have them, because the data sets are so big, the sort of the inbuilt CVS snapshots doesn't work for that data set we have. But for other smaller lab sequences or lab devices we have, or other different systems, the snapshot process is pretty good in the NetApp product. So like I said, we wrote our own backup solution for the sequencers using Lambda functions, which launch instances attached to the NetApp volumes just as another client, and they synchronize the data off to an S3 bucket anyway. So, that's the nice thing, that we just plug another product or another service into it ourselves, just to get our use case to work.
So you back up to S3. You're exporting to S3 too, right?
That's right.
The data set. So when you're doing the exports or the backups, do these take a long time? Are they slow? Are they what are the?
Well, I think the fact that we've got a 10 gig pipe out of the building really does help. It's a nice luxury to have, and it really does make a big difference.
Okay. So all said and done, you guys are, you've tried something different. You're kind of forward thinking. You have huge data sets, which equal huge problems, right? Or huge
absolutely.
Challenges.
Yeah.
You guys are doing such cool stuff. there were a couple big things that you guys liked out of it. Would you rank them? Would it be cost savings? Would it be efficiency gains? Would it be more hours in the day?
Less sleepless nights is probably the first one that we're not worrying about servers that we've rolled ourselves. Also, like I said to you, the whole aspect of management. I think that's something that kind of goes under the radar for a lot of people. They don't realize if you're rolling your own solutions, you got to commit an awful lot of time and a lot of resources to make sure it stays running, it's optimal, it's performing the way you expect it to run. So taking that out of the equation, that gives me a lot more resources to do other things and, work on other systems.
Well, here's the fun part. This is, can you take everyone through, what this looks like from sequencer into, getting a sequenced data set exported there?
Right, so like we said, we start off with the sequencers that are generating these large data sets. And once you've processed the actual blood and turned it into digital data, they're then written to a Windows file share, which happens to be the NetApp volume there.
And these are, I think too, what I want to hit on is these devices are mounted to an AWS NetApp volume.
That's right, yeah. So
they're mounted.
There's no physical equipment in play apart from the networking infrastructure.
Many miles away.
Yeah.
Many miles away.
So as an organization, like I said, we've heavily invested in our network infrastructure. So like we've got a 10 gig direct connect from Amazon. We've also got a microwave radio link on the roof there. So should that direct connect fail, we have another mechanism to get to the actual VPC that's actually attached to your cloud volume. So we have a lot of infrastructure there. So that's where we spent our money. We did a smart spend on the infrastructure rather than actually physically rolling a lot of storage devices into our environment and then figuring out how we're going to support them and keep them running.
And so we've got the
sequencer, so
right?
We've got our data moved across the direct connect onto the NetApp volumes. We then have our pipelines which will kick off. So we basically use an awful lot of Amazon auto scaling. And like I said, we can launch between 100 to 400 instances to actually take all that data which we've collected from the sequencers, which is now sitting on a NetApp volume, and then they basically process that data, convert it, and make it into a usable format. We'll do our own QC on that on those files, make sure what we got off the sequencer is a valid sample, because you will have sequencers sometimes they might fail or there might be a bad sample. You don't want to commit that data into the cloud. Storage is expensive.
Yeah.
And then after we've done all that processing, we basically push those files to S3. And that's where the real magic starts. Like I see ourselves as basically the plumbers. We're looking after all the actual engineering. And that's when the super smart people, our scientists and our bioinformaticians can do something with that data that we've collected.
And that was, okay. And then, so we got the dual protocol links, right?
Yeah,
the SMB and the NFS.
Absolutely, yeah.
There.
So the SMB for the sequencers and the NFS for the pipelines.
Awesome. So we're going to do a demo. Oh no, we're not going to do demo. Okay. Well, let's talk about future. What is this like from what you've done so far? Do you have ideas of how you would change things, or what you would do in the future, or does this open up new projects? Or
yeah, no, we're looking at a lot of ways we can reuse this product. Like we use an awful lot of spot instances in our pipelines because you get a lot of cheap instances at a very reasonable cost. So these machines that are doing this processing after we've got the data onto NetApp volume. So we're talking about a couple of hundred instances that can have 2 terabyte drives on them, AWS drives. Which, if you're running, say, 400 of these machines for 15, 20 hours, that's a lot of, and if you're running that a couple of times a week, that's a lot of EBS storage you're paying for.
Yep.
And the problem we also have is, Spot can go away. And if you have a situation where that data is sitting on a Spot instance, you've got 2 scenarios. You might, say, hibernate a Spot instance, or you're going to lose that data. In our scenario, the hibernation wouldn't really work, just the size of the data sets we're working on. One thing that we're playing around with the idea is, if we launch these instances with much smaller drives and use the NetApp volumes themselves to hold the processing data, we might be in a position at a later stage to either pick up those jobs where they left off when we get back to Spot again, or we can have, say, a smaller fleet of, say, on-demand instances or reserved instances which chip away at say jobs that weren't completed. So we're not quite there yet. It's not a viable product, but it's a direction we're kind of looking at the moment.
But that's smart. It's a good use of resources. So was this our last slide? Sorry.
Yes, anything else?
I don't know why that was in there, but yeah. Thanks for doing the talk. It's like
No problem.
It's like a panel presentation.
Yeah.
So do we open it up for questions? Does anyone have any questions for
Yep.
Jason, who's doing cool stuff here?
Do you run into, I mean, at the company I'm at now, we use physical net apps for ages with NFS on the front, and we still run into locking problems sometimes, even with, just directing one. So do you run into any NFS locking problems, being that it's distributed out?
No, we haven't hit any problems yet on the actual cloud volumes.
Okay, so it's no different than physical storage?
No, they're, as far as they're concerned, they're talking to real storage. Well, I think maybe our process flow might be different because you have a situation where the actual front end devices are basically pushing all that data. Then once that operation is complete, you've got your fleet of NFS drives. So it's kind of almost like a print flow. If you think of it like a print server, you're kind of going one direction.
Okay. All right. Yeah, we're doing a lot of mixed IOPS.
Yeah.
Collisions and, so that's always fun. And NetApps do great, and we're trying to move into the cloud with that. So
Yeah.
that's, part of the challenge.
Sorry, Jeff. There's one other thing I actually forgot to mention there. We brought our last sequencer online there recently, and just the whole setup for that instance, that sequencer, it took 24 minutes.
Versus what did it take before?
Well, like I said to you, when you had to build your other the other storage solution, you were talking about an hour or two to stand up your instances and do your replication tech and make sure you're happy with that you're getting your data. But the other thing with this 24 minutes, it actually took 20 minutes for my IT guys to network the sequencer and do all the network security and get it on the wire. And it took 4 minutes for the DevOps guys to create the NetApp volumes and basically change the endpoints on the pipeline so they knew that was there. So
That's cool, yeah.
again, that's just a kind of thing. And from our perspective, we can just horizontally scale. Like we actually create new NetApp volumes for every sequencer we have on site. So rather than a situation where you run out of physical capacity or you're into spinning up more instances, we just create a new NetApp volume, do a bit of configuration on our pipelines, and away we go.
I think that's how you're going to hit 10% of Ireland.
Yeah,
for that
absolutely.
scaling. We can talk later too about yours. You can have multiple volumes that have different SLAs that you can work with, and it's built for multi-tenancy to handle that. So
I'm just worried about latency, I guess, because you are kind of stretching it further away from. You're a little bit further from the source, kind of thing. Because now you're going through the cloud. In your case, you're probably going really far away. Yeah, I'm just wondering about the latency.
It hasn't been a problem, I have to say. It's been very good. Like we're literally able to pull files on and off, or even the own internal network as well. We've got 10 gig in a lot of these environments internally, and you wouldn't know cloud is there.
what else? Any other questions? Awesome. Well, thank you, everyone. Thanks for coming out.
Great. Thanks, Jeff.
Is your water?